Today I'm presenting you with a question. This question has been posed to scientists all across the world. How many species are on Earth and in the ocean? Camilla Mora and associates from the Department of Biology, Dalhousie University, created a method to answer this controversial question. New species are found and described every year. These discoveries mean that our current databases are incomplete with an unknown amount of unidentified species. To generate a model prediction, all known species information was correlated. The number of species on Earth were based on the classification of species from the Catalogue of Life, while amount of species in the ocean were founded from the World's Register of Marine Species. The compiled information was only inclusive of data up to 2006. This was done to prevent any discoveries of the descriptions of animals that have not yet been entered into the database, creating artificial information. After compiling information on the discovered species, Mora and her co-workers then put an asymptotic parametric regression model for the taxonomic vague to account for the species that were yet to be discovered. These graphs show the accumulation of the taxa, which are indicated by the black lines with the graph. The horizontal dashes portray the consensus asymptotic number of the taxa, and the horizontal grey are the standard error. For graph 1G, the black circles show the census asymptotes, the green circles the catalogue number of the taxa, and the box at the species level represents a 95% reliability of the predicted number of species. By applying fitted models to these different asymptotic ranks, the models were used to predict the number of species. The approach was applied to 18 taxonomic groups whose total species amounts were thought to be well known. It was evident that this method produces results that are consistent with the recorded totals of the selected species. This approach was then applied to all eukaryotic kingdoms. The predicted totals shown are far greater than the totals that have been catalogued. From this approach, the total number of the Earth species can be derived. The total prediction for the number of species on Earth and in the ocean is more than 6 times the amount of species catalogued. It is important to remember that these values are only an estimation and have numerous factors that can influence the interpretation and strengths of the results. The progression models were based on the discovery rates of species prior to 2006. If there is an influx of new discoveries or a change in the classification, the models would be inaccurate. It is important to have an understanding about the diversity of life on Earth as a reference point for present and future losses of biodiversity. Incomplete sampling and lack of strong-footed approaches creates uncertainty and controversial estimates of the number of species on Earth. Mora and her colleagues devised an approach that was validated by existing inventories, constructing strong grounds for the predictions. Previous studies have shown that current catalogues are biased towards certain more obvious species, which suggests that the remaining unknown species in the world inhabit small range and possibly concentrated areas. Results from this report can provide basis to continue and expand the predictions and perhaps even spark interest about the world we live in and the species that inhabit the planet. The question we are now left with is, where are these undiscovered species?